Hello everyone. Today we'll have an interesting journey through world of calculus. So let's begin. So first, classification. Calculus can be classified into two categories. First is differentiation, second is integration. And calculus comes into picture when there are two variables associated with the problem. Suppose it can be pressure and volume, or it can be displacement and time, anything, any two variables. So the first category, differentiation, is always associated with change of one variable with respect to another variable. Like this. Say it can be pressure and volume, change of pressure with respect to change of volume, ratio of this change. And the concept of integration comes into picture when we want to sum these changes. Suppose there is a change in pressure due to change in volume, and we want to sum the changes of pressure with respect to volume. Then integration comes into picture. Like this. Don't worry about this concept right now. We will see a simple example and we will try to understand what is real meaning of this. Okay. So let's proceed to a simple and funny example. And this is our experiment or example. What I am going to do, I am just dropping an apple like this. Comes down, finally on ground. So this experiment we will do two times. First for understanding differentiation, second for understanding integration. So first let's go to differentiation part. Apple drop experiment for differentiation. Here I have got one scale which is to measure height of the apple. So I am releasing at height of 1 meter, and I have got a timer here, and timer will always count the time and position will be counted from the scale. So let's release the apple, and we will count the position in each 0.5 second, so it will be somewhat accurate. So we are starting the experiment, and apple is coming down. You can see at 0.5 second it has traveled 0.04 meter. At 1 second it has traveled 0.1 meter, like that. Finally it travels, reaches on the ground. Now you have two series of values. One is time at 0.5 second interval, next is position at particular time, 0.5, 1, like that. So using this data we can have some interesting calculation. Since we know position of apple, let's try to find out velocity of apple at each time. And you know velocity is nothing but change in displacement with respect to change in time. So that's the definition of velocity. Here I have replaced the data again, and at time t is equal to 0, velocity is change in displacement is 0.04 minus 0, and change in time is 0.5. At time t is equal to 0.5, change in displacement is 0.1 minus 0.04, change in time is 0.5 again. So likewise we can calculate up to third second. It will be 1 minus 0.74 by 0.5 again. And we won't be able to do 3.5 because you don't know value at 4. We can calculate up to third second. Now the process we did to find out velocity, this is known as differentiation. Let's generalize this. Velocity is equal to what we had done just now. We were at position x at time t, and we found out position at delta t plus t, and we found out difference of that, and we divide by delta t. You can compare it with the previous example, and this is what we have done just now. So there is a small question from my side. For this example we took delta t as 0.5. What about if I set some other value? What if I reduce the value again, make it 0.4, 0.3, 0.1, 0.001? If I do so, suppose I am taking it very small, then both numerator and denominator will always tend to 0, as you can see from this equation. At that condition, the velocity I have found out will be very accurate. When I took delta t as 0.5, it is not so accurate, but if I take it very small, is really near to 0, my velocity value will be quite accurate. So if we can make it such a condition, then that scenario is known as differentiation. Here is a condition. When delta t tends to 0, this expression will be called as dx by dt, or differentiation of x with respect to t. As simple as that. Okay. Now let's analyze the same experiment graphically. That will give you more insight about the problem and differentiation. So we have plotted the same data in graphically, time t in x-axis and displacement x in y-axis. And let's find out differentiation at time 1.5 second. We can see delta is equal to this x minus this x, so remaining is this much, and change in time is this much. And when you divide this by this, you can see you are forming a line here, and what you are finding is tan theta of this angle, if there is a small angle here. And so you have doubt that this line might be tangent to, so you will obviously have a doubt that this line might be tangent to this curve. So tan theta of tangent is slope of the curve. Yeah, you are right. Differentiation graphically means slope of the curve. But let's zoom it again, this curve. When I am zooming, what I see, this is what I see. You thought this is tangent, but this is not exactly a tangent. This is crossing the curve. It will be a tangent only if I reduce delta t to a very small value. At that position, it will be exactly a tangent. So differentiation graphically means slope of the curve when delta t tends to 0. So differentiation part is over. Now we are able to find out differentiation at any point.